Now let's look at how we can prepare the model for 3D printing. When printing threads, it's common for the fit between the bolt and nut to come out either too tight or too loose because of slight variations in printer accuracy. To fix this, you can adjust the scale of either part, the bolt or the nut, to fine-tune the fit. In this case, I'm going to adjust the nut. I'll start by copying it to create 2 duplicates. This way, we can test 2 different fits after printing. Next, go to the Modify menu and select Scale. For the first nut, I'll increase the scale by 5%, and for the second, I'll increase it by 10%. Or you can make copy of 2 bolts and reduce the scale by 5%, and for the second, reduce by 10%. These small adjustments help you find out which one gives a smoother thread engagement once printed. By printing both versions, you can compare how each one fits on the bolt and decide which scaling gives the most accurate result for your specific printer and material. Now that our parts are ready, let's move on to the 3D printing setup. The first step is to convert the models into STL files, since that's the format most slicers, including Bambu Studio, use for printing. In Fusion 360, simply right-click on the component, in this case, the bolt and nuts, and select Save as STL. You can export them together or one by one depending on how you plan to print them. Once the files are saved, let's open Bambu Studio and import them into the workspace. You'll notice that Fusion sometimes exports multiple parts as a grouped object, which means they move together as one unit. To fix that, I'm using the Split Object feature in Bambu Studio. It's a quick and handy tool that lets you separate the grouped parts into individual components. After applying the split, you'll see all 3 parts, 1 bolt and 2 nuts, listed separately in the object panel. Now, we can start arranging them on the build plate. When positioning the parts, the goal is to avoid using supports whenever possible. Supports can interfere with the accuracy of small features, especially threaded sections, and might require extra cleanup after printing. The nuts are easy, they have flat faces, so we can lay them directly on the build plate without any supports. This helps achieve a clean and precise thread finish. The bolt, however, is a bit more challenging. Because the bolt head isn't perfectly flat on the bottom, the slicer detects an overhang and automatically adds supports underneath. You can already see that in the preview, and while supports aren't a big issue, they can reduce surface quality and make the thread slightly rough after removal. But there's a simple and efficient fix for that. To fix the bolt for easier printing, select one of the hex faces on the bolt head and start a new sketch. Draw a rectangle across the top to cover the uneven area. Then, go to Create Right-Pointing Arrow Extrude, set it to Cut, and select the full profile you just sketched. Make sure the cut goes through the entire bolt head. Now you've got a clean, flat surface that will sit perfectly on the print bed. Export the model again as an STL file, open it in Bambu Studio, and you'll see the bolt now places flat, no supports needed. Now let's move to the final stage, printing the parts. Start by opening a new project in Bambu Studio and importing the updated STL file with the flat bolt head. Once it's loaded, we'll need to split the objects so we can manage each one separately. Just like before, right-click and choose Split Object. This separates the bolt and the 2 nuts, giving you full control over their placement. Next, let's arrange the components on the print bed. Make sure all the parts are lying completely flat. This is important because printing directly on the bed gives you cleaner surfaces and ensures the threads come out more accurate. Since we fixed the bolt head, everything now sits flat, meaning we can print without any supports at all. No supports also means faster printing and smoother threads that don't need cleanup later. Everything's ready, so it's time to start the print and see how it turns out. Once it's done, we'll test both nuts and find out which one gives the best fit with the bolt. Now the print is done. Let's check how everything turned out. Before testing the fit, let's take a closer look at the print quality, especially the bolt and the threads. Because we printed without any supports, the threads came out much cleaner and more precise. When supports are used around fine details like threads, they often leave small marks or rough edges once removed. That can make the nut harder to turn or cause binding between the threads. You can already notice a slight difference in the nut sizes, depending on the scaling we applied earlier. Let's start with the 5% scaled nut. As I thread it onto the bolt, it fits well, but it's definitely on the tighter side. In some cases, a tight fit can actually be useful, for example, when you want the nut to stay firmly in place, so the 5% scale adjustment works nicely for that. Now, let's try the 10% scaled nut. You can see right away that it threads much more smoothly. It's not too tight and not too loose. Honestly, it feels just right. So for this setup, I'd recommend using around 10% scaling for the best fit and print accuracy. That wraps it up. Thanks for watching, and if you haven't seen how we designed and inserted these fasteners directly in Fusion 360, without any manual drawing, make sure to check out the previous video. Hope you enjoyed this one, and I'll see you in the next video with more Fusion 360 and 3D printing tips.